Every second somewhere in the world, thousands of containers are being created, destroyed, scaled, and removed all automatically. But have you ever wondered what technology orchestrates this invisible symphony that powers Netflix, Spotify, Uber, and even your banking apps? Yes, that technology is Kubernetes. So, what exactly is Kubernetes? We'll keep it really very simple. So, what exactly is Kubernetes? So, Kubernetes is not a tool. So, Kubernetes, basically, first we'll go with the definition. So, Kubernetes is a container orchestration tool. Orchestration tool. So, it is not just a tool, it is a self-driving operating system of the cloud. We can understand it like a self-driving operating system of the cloud, right? So when we use Kubernetes, like let us understand it this way. So before using Kubernetes, we would have we would worry about some of the basic problems like managing servers, and then there were another problem of like manually deploying containers. At the same time, if the containers fail, then we should also worry about their failures. So container failures was also a problem that was in front of us. But when Kubernetes came into play, so Kubernetes handles all of the above automatically, right? So it ensures that the application stays up all the time, it scales as per the requirement, and it recovers by itself or heals itself if there is a problem, and it remains consistent over the thousand of servers on which upon it is deployed. So that is the beauty of Kubernetes. And one more fun fact, Kubernetes is often spelled as, for example, if you see Kubernetes, it is also written as K8s. So the reason why is like before K and before S, like in between K and S, there are 8 characters. So that is why it is called as K8s. It's an interesting fact, right? So now let us move ahead and then let us understand what kind of architecture does Kubernetes follows. So Kubernetes follows some of the architectures that is over here. And before understanding this, we have to understand two high level layers on which Kubernetes work. That is, first layer is called as the control plane. So control plane is the first layer. And what is control plane? Understand it like the brain of Kubernetes. And then there is a worker node, which is the muscle which does all the action. Worker node or worker plane, and it is the muscle of Kubernetes. So control plane decides what? Control plane decides what should happen. So control plane, let me put it here, it decides what should happen, and the nodes or the worker plane decides like how to execute whatever is requested, or we can tell that how it should happen. Whatever task is there, how it should happen, right? So moving on to the first cluster type or architecture type, it is a single node cluster. So node is nothing but a virtual machine, kind of a machine on which the Kubernetes setup is installed. So understand it like a VM. Now understand it is a simple node or a simple machine on which we have both the parts of Kubernetes or both the section of Kubernetes. One is the control plane and another is the worker node. So control plane and worker node both sit on a single node. That is why it is called as single node cluster. So here is the control plane and here is the worker node. So what this is generally used for? So this particular architecture of Kubernetes is generally used for so this particular architecture of Kubernetes is generally used for some of the basic like learning purpose, because it does not require heavy load bearing. So that's why we have not added many virtual machines over here or many nodes over here. Then it can also be used for local development and some of the local testing as well. So these are the use cases of single node cluster. Moving on to the second, which is the one master, one worker. So this is one of the most common architecture that we can see. Here we have got general two nodes. So one node, the first node is called as the control plane, and it interacts with a worker node. So this is your worker node. So this is a communication between a control plane and a worker node, right? So this is a small scale production or a pilot setup. It is kind of a small replica of prod, and it is also, it gives you a workload isolation while keeping the things lightweight. So this is one of the most common setup, that is one master, one worker. Moving on to the third type, which is one master, many worker. So here one master, many worker is kind of a, we can call it a standard prod setup. So this is a standard prod setup over here. And this is where the real application begins. We can use this particular cluster type for what? We can use it for high performance. Then there is also good distribution of load, because here not only a single node is handling all the load is distributed between all the three nodes. So these three are your worker nodes, and here is your master node or control plane. So this is your master node or control plane, right? And this is what the most medium-sized companies run, right? And then we move on to multi-master and multi-worker. So here you can, as the name states, here there has to be multi-master setup over here. So these be your control plane or the master node, and there are multiple worker nodes. So let's say these two are handling these two are handling these two, but at the same time, since they belong to same cluster, there is also communication between all these. So this is again used for enterprise level. So what this particular architecture is used for? Generally for enterprise level architecture. Right? Multiple master ensures that cluster continues even if one fails. Like let's say if our master node gets compromised, so if this gets compromised, even this is available, and this is taking care of the entire cluster, making sure that the cluster is not down, right? So this setup is the backbone of mission critical systems, like for example banking, e-commerce, streaming platforms. So these all are the places where this gets used. So what all areas we can use it? Banking is there, then there is e-commerce, and then there is streaming platforms. So all these areas, this kind of architecture is generally used. Now let us understand, let us move ahead and see what a node really is. So if you see what a node really is, node is nothing but simply a worker machine. So what is a node? A node is basically a working machine. So working machine, and this working machine can be physical, your server or your laptop, or maybe virtual, like your VMs or maybe cloud, where upon which we run our container, right? And this particular virtual machine, so what did we understand? Let's say this is our node or a machine that is physical or virtual, and upon this we run our containers. So these are our containers in which our application runs. So this is nothing but a node setup. So what all metrics do we see for a node? So all the metrics that we see for a server is what we see for the node also. So the metrics are, it should have a certain CPU, it should have certain RAM, it should have certain storage, it should have container runtime, the machine or the software which will spin or spawn containers. So this is what we call as container runtime. Container runtime is also there, and the Kubernetes agents which will monitor these container runtime. So this is what a node is, right? So we can think of node like a, what kind of we can think it like a mini data center, which is waiting for instructions from master node and then executes. This is your worker node. So node is nothing but a working machine, maybe physical, maybe virtual, that runs containers for us, right? Now moving ahead, let us deep dive into Kubernetes architecture in detail, right? So let us explore the control plane first. So if we see the control plane over here, so this is my control plane. So let me draw the architecture of the control plane for you. We have got a reference image also. Okay, so this is the control plane. Let this be control plane. So control plane has got certain key elements or objects that makes a control plane. So the first one is your API server. So what is this? This is your API server. So what does this API server do? API server is basically the front door. Every command, every request, every update passes through it. So this is the only that talks to, this is the only component that talks to other components. No component in Kubernetes talk to each other directly, but only with Kube API server or API server. Then we have got another important Kubernetes component over here that is called as etcd. What is it? It is etcd. So etcd is nothing but your memory or your storage. What is it? It is your memory. So it is a distributed key value store. So here the data is stored in the form of key value pairs, right? So it is a distributed key value store that holds the entire cluster state, entire cluster information. Which node has got what pods running, what is the current load, is there any cluster, is there any node that is failing, or is there any requirement to provision new node, is there any pod that is failing? Each and every detail is stored within the etcd. So if you lose etcd, if somebody hacks this etcd, then the entire cluster gets compromised. So this is very important. So again, etcd can only be communicated by Kube API server. Nobody else can communicate with etcd. Third is a scheduler. So this is your scheduler. What is it? This is your scheduler. Let me remove this control plane for now so that we can write it. Okay. So this is your scheduler. So what does scheduler do? Scheduler is the matchmaker. So it matches pods with the nodes based on resource availability, policies, and performance needs. So it is basically taking the command from control manager and does all the scheduling work. It only checks for resource availability. It checks for resource availability. Then it also checks for policies, performance needs, and then decides where the application should run on. So for example, if you are requesting any pod, new pod, then it is the scheduler who decides where that pod will run, or basically on what node this will run. So this is scheduler. Now scheduler also interacts with only Kube API server. And finally, the brain behind everything is called as the control manager. So let this be your control manager. So this is your controller manager. Right? So this ensures that cluster always matches the desired state. So its role is to see current state equals desired state. So what does this mean? Let's say we have got 5 pods running, that is the current state, and the desired state is 7 pods. So it will then reach out to scheduler. It will then reach and it also interacts with this Kube API server. So it goes to, how does it fetch information? So control manager goes through, fetches the data from etcd via Kube API server, and then looks for the current state. So current state value is 5. And what is the desired state? So desired state is 7. So what it will do, it will again give the command to scheduler that we need to run 2 more pods, and then scheduler schedules 2 more pods. So that is how it works. So that is the control plane, right? Or the master node. Now moving on to the second part, we'll go to the worker node setup now. So let us understand the worker node. So what does worker node says? Worker node, let me draw this worker node for you. Let me draw it a little bit in the middle. So this is your worker node. So worker node first has got pods. So let this be your pod. Pod is one of the most important entity of Kubernetes. It is the smallest running unit in Kubernetes. It is the smallest running unit in Kubernetes. And it contains one or more. So what does pod contain? Pod contains containers. So this is your container. So pod contains container, or container is encapsulated under a very small deployable unit in Kubernetes that is called as pods, right? Kubernetes never deploys containers directly. It always deploys inside pods, and each pod get its own network space and IP address. So each and every pod has got its own IP address also. Moving on to the second important component, that is called as kubelet. So this is your kubelet. So what is kubelet? Kubelet is the local supervisor, or kubelet is the agent that runs around the Kubernetes and runs around the worker nodes and have all the information related to the cluster. So it ensures, what does it ensure? So it is what it is an agent that runs around worker node. Second, it ensures that containers are running in a state that control plane expects. So for example, control plane has given the instruction that there should be 10 pods running. So it is kubelets who make sure that the 10 pods are running, and then it also communicates with the control plane that your requested 10 pods are running perfectly well. And if a pods also crashes, then kubelet restarts it. So it does that work also. And later on, moving ahead, there is also a component called as kubeproxy. Now what is this? This is kubeproxy. So what does kubeproxy do? Kubeproxy basically manages communication within and outside the cluster. So it all does the pod to pod communication, and all that pod to pod communication and networking related work is taken care by kubeproxy within and outside the cluster. It ensures that services can talk to each other. And later on, we have got a container runtime. So this is your container runtime. So what is container runtime? Container runtime, basically it could be container D or cryo. And initially it was we used to install Docker as a container runtime. So it is basically, for now, let us understand, here we have installed Docker. Why? Because we have to spin containers. So as soon as we get a request to, let's say, spin 5 Nginx pods over here, then the request goes to this particular container runtime, and it spins 5 containers under each and every pods. So that is the role of container runtime, right? So what are some of the key elements that we have seen? So let us understand the flow once more. So this is your master node, and master node has got a, let's say, this is a API server. API server again then talks to etcd database, which is kind of a storage which stores. So this is etcd, and it has got cluster data. Then it has also got scheduler. So this is your scheduler. So scheduler does all the scheduling of pods into what nodes, basically getting all the details of the worker node and then scheduling the pods over them. So this is what it does. And then there is also, this is your control plane or controller manager. Sorry, this is your controller manager. Controller manager takes all the calls, and it is basically the brain behind everything. So API server again interacts with your etcd. It also interacts with your scheduler. It also interacts with your cluster or controller manager. Nobody communicates directly. It is via API server. Everyone communicates. Even we as a user, when we want to communicate with the cluster, for example, we want to run any commands, we are talking to Kube API server. And then Kube API server, for example, you want to deploy a pod. Then Kube API server goes to controller manager. Controller manager then asks Kube API server to check the status. So it then goes to your etcd, fetches the data. Current state, okay, current state is 5, desired state is 6. Then it goes to scheduler and asks scheduler to schedule a pod. Then scheduler looks for appropriate nodes where that pod can be scheduled, and then asks to deploy the pod. So that is how the master node or the control plane works. Now let us see, just a second. Okay, now let us see worker node. So here we have got the worker node over here. So worker node has got again 4 components over here. So we'll quickly go through them. So first one is your pod. So this is your pod. Pod is nothing but a smallest deployable unit under Kubernetes, which has got containers running inside them. And where is this container coming from? Container is coming from the container runtime. So this is your container runtime, which is spinning pods. And then there is a Kubelet. So kubelet is an agent that runs across the worker node and then gives the update to the master node. So this is the agent which gives all the update to the master node. And then we have got kube proxy. So this is kube proxy, and kube proxy does all the networking. So this is how it communicates. So kubelet again communicates with kube API server. So that is the basic architecture of Kubernetes, right? Now we will see how everything works together. So how does the communication in Kubernetes work? So we have to communicate with Kubernetes, in the form of a manifest file. So manifest file is nothing but a YAML file. So we have to create a YAML file. We'll all cover these all, in the upcoming videos. But again, so the YAML file could be of what? Could be of pod creation, could be of deployment, could be of service, and everything. So if we have to get a pod or a deployment or a service created, we have to write a YAML file because Kubernetes only understands YAML file. Then this YAML file goes to Kube API server. So this is your API server. Then Kube API server desired state is recorded in the etcd. So Kube API server records this in etcd. Okay, that this is the desired state. So for example, we want to create a pod. So this is then stored. It's stored in the form of desired state, right? And then scheduler selects a node. So no, then it goes to controller manager. Now controller manager sees, okay, the requested state is 5 pods and the desired state is 6 pods. So that it goes to Kube API server again, and Kube API server goes to your scheduler. So scheduler selects a node and then kubelet on that node. So scheduler selects a node and then kubelet on that node creates a pod. Container runtime creates the containers and kube proxy manages the traffic. And then controller monitors everything has been done correctly or not. So this goes to container runtime. Container runtime creates containers. Container runtime creates containers which is deployed inside pod. And then there is kube proxy. Then kube proxy does all the networking. So this is the entire flow of Kubernetes work. Now where can we deploy Kubernetes? So Kubernetes deployment of Kubernetes, or deployment or configuration of Kubernetes. So Kubernetes can be deployed on bare metal in your local system also. Then we have got virtual machines on that also. Then we have got private data centers where this can be deployed. We have got public cloud like AKS is there, EKS is there, GKS is there, Azure Kubernetes Service, Elastic Kubernetes Service, Google Kubernetes Service. Then we have also got hybrid and multi-cloud. There is also what we can install, and we can also make spin up virtual environments, or spin up these labs on your laptop using Minikube kind and everyone and these kind of tools.